Hello everyone, my name is Tooshika and my supervisor is Dr. Richard Goulet. Today I will be presenting my final year project entitled Determination of Environmental Criteria for Polonium-210 in Freshwater Ecosystems. Polonium-210 is a naturally occurring alpha emitter which is a product of the radioactive decay of uranium-238 and is released via effluent discharge from uranium, oil and gas and coal mining. With its limited solubility in water, polonium-210 tends to get adsorbed to mineral surfaces and particulates dissolved and suspended in water. Hence, it accumulates preferentially in bottom sediments. Aquatic organisms in water bodies that are exposed to the polonium-210 are not only at risk of internal tissue damages, but can also potentially bioaccumulate the polonium-210 and threaten lives of other organisms along the food chain. Therefore, the purpose of this paper is to attempt to determine a safe level of polonium-210 in water and in sediments for freshwater organisms, as polonium-210 and its effects have not been very documented in Canada. We therefore hypothesize that the effect of polonium-210 and its bioaccumulation by freshwater organisms are linked to its concentrations in water and sediments. The methodology used is as follows. A literature review was done using keywords such as polonium-210, uranium mines, freshwater organisms, bioaccumulation dose rates, only to mention these, on Google search engine to obtain scientific peer-reviewed papers and reports, namely the IAEA reports. Using data from different scientific papers and reports, a database containing activity concentrations of polonium-210 in freshwater sediments and 41 freshwater organisms was built after standardizing the data. ERICA software was used to calculate the total radiation doses of polonium-210 in each organism, and results were tabulated in the same database. An ANOVA test was performed on GraphPad Prism. Graphs of total radiation dose rates of each species group were plotted against the concentrations of polonium-210 in sediment and water. A correlation analysis was then performed on GraphPad Prism. Lastly, water and sediment criteria were derived using the graphs in comparison to a reference line at 10 microgray per hour, which is a value used by Brown et al. In the creation of the new ERICA tool. The ANOVA test performed showed that there was a significant difference between groups, as shown here on this slide, as the p-value was less than 0.05. All radiological benchmarks associated with polonium exposure are below the 10 microgray per hour limit. Below this limit, freshwater organisms are safe. However, bioaccumulation of polonium varied from one species to another. In general, there are no relationship between polonium in water and sediment and bioaccumulation in most groups of organisms except pelagic fish. This suggests that polonium in water and sediment are at levels that are not available for uptake for most species. For pelagic fish, however, the graphs on this slide show a significant relationship between radioactive doses associated with polonium exposure and polonium levels in sediments and water. This means that the pelagic fish may be less able to maintain polonium levels in their tissue in response to increases in polonium level in the environment. Using these significant relationships, we obtain a water quality criterion to protect pelagic fish of 0.26 becquerel per liter and a sediment criterion of 848 becquerel per kilogram. According to the radiological benchmark set by the Oak Ridge National Laboratory in Tennessee, the benchmark for fish in water is 26.825 becquerel per liter and a sediment benchmark of 4,033 becquerel per kilogram. Our criteria are lower. In conclusion, this study shows that polonium levels in the environment are currently not of concern to freshwater organisms. However, Considering the future change in demands for uranium from nuclear reactor in China, new oil and gas and coal projects, as well as the possible emergence of small modular reactors, it is possible that polonium exposure may increase in the future. As a result, we recommend to conduct toxicity experiments in water and sediment to set adequate water and sediment quality criteria. Thank you.